So we'll look at question 1, determine the molar mass of silicon tetrachloride, SiCl4. You can either use your periodic table or the app to do this. So silicon has a mass of 28.0855. Each chlorine has a mass of 35.453, and we have 4 of those. So that's going to be 141.8. Molar mass should be on the order of 169.9. Remember, it needs to be grams per mole. If you have the right number but you didn't put the unit, then you're looking at 3 out of 5. If you put a unit but put the wrong unit, you're looking at 3.5 out of 5. All right, number 2, how many moles are present in 5.12 grams of calcium carbonate? I want to start with what I know. 5.12 grams of calcium carbonate. My conversion factor is 100.1 grams of calcium carbonate. Again, that's the molar mass, is equal to 1 mole of calcium carbonate. So all we need to do now, first of all, grams of calcium carbonate cancels. Just a simplification step now. 5.12 divided by 100.1. I get 0.051 moles of calcium carbonate. Your answer might vary just a little bit if your molar mass has more significant digits. But if it's along the lines of 0.051 moles, then you should expect to obtain all 5 points on that question. All right, number 3, how many grams are in 0.000143 moles of tetrahydrocannabinol? 0.000143 moles of C21H30O2. We know that 1 mole of THC is 314.46 grams of THC, and moles of THC cancel. And the answer we get is 0.045 grams of THC. Okay, finally, number 4. This is the one that's the 3-step problem. So again, we want to begin with what we know. 1.0543 grams of THC. We have 314.46 grams of THC in 1 mole of THC. We know that 1 mole is 6.022 times 10 to the 23rd molecules. And we know that 1 molecule of THC has 53 atoms. Again, our formula is C21 H30O2. 21 plus 30 plus 2 is 53. Now I can cancel out units. Grams of THC cancel. Moles of THC cancel. Molecules cancel. And now my answer will be in atoms. So all I need to do now is to simplify this expression. So we have 1.0543 times, now when you put this into your calculator, use parentheses. Parentheses 6.022 e to the 23rd, parentheses, enter, times 53, divided by 314.46, and I get 1.07 times 10 to the 23rd atoms.